Hi everyone. In this class, we are going to discuss about mutual perpendicular relation between electric field intensity and magnetic field intensity in uniform plane wave. The electric field intensity E bar and magnetic field intensity H bar are perpendicular to the direction of the electromagnetic wave. The Maxwell's equations for time varying fields are given by, and one of the differential form of the Maxwell equation for time varying field is del cross E bar is equal minus dou B bar by dou T. But B bar is equal to mu into H bar, that is equal minus mu into dou H bar by dou T. We know that according to the basics of mathematics vector analysis concept, if there are capital A bar and capital B bar are the two vectors, the cross multiplication of two vectors can be represented into vector notation. So now here del is the vector operator, vector differential operator, and E bar is the vector. So what is the vector differential operator del? Del is equal to dou by dou x ax bar plus dou by dou y ay bar plus dou by dou z az bar. And the vector form of the electric field intensity E bar is Ex Ax bar plus Ey Ay bar plus Ez Az bar. So using cross multiplication of two vectors, the LHS term of this equation using matrix notation can be represented as Ax bar dot Ay bar Az bar and del magnitudes, vector differential operator del magnitudes. Ax bar component is dou by dou x, Ay bar component is dou by dou y, and Az bar component is dou by dou z. And the second vector is E bar. What is Ax bar component? Ex, Ay bar component is Ey, and Az bar component is Ez. Okay, del cross E bar, cross multiplication of two vectors can be arranged in the form of vector matrix notation is equal minus dou by dou t into B bar. So similarly, the magnetic flux density B bar in vector form. In Cartesian coordinate system, the vector form of the magnetic flux density B bar is Bx Ax bar plus By Ay bar plus Bz Az bar. So LHS side, for uniform plane wave propagating in z direction. So the condition of the uniform plane wave. What is the condition of the uniform plane wave? For uniform plane wave propagating in z direction, it has no x component and no y component. That is, dou by dou x is equal to 0, dou by dou y is equal to 0. It has no Ez component and no Bz component. If the wave is propagating along z direction, along z direction, there is no electric field intensity and there is no magnetic field intensity. So along the z direction, what are the components? Ez and Bz are the components along z direction. So Ez is equal to 0 and Bz is equal to 0. Applying uniform plane wave condition to above equation. So therefore, Ax bar, Ay bar, Az bar, dou by dou x, dou by dou y is 0 for uniform plane wave, and for uniform plane wave, Ez is equal to 0 and Bz is equal to 0. So using vector reducing the above equation, Ax bar into 0 minus dou Ey into dou by dou z minus Ay bar into 0 minus Ex into dou by dou z plus Az bar into 0 into Ey minus 0 into Ex. So LHS term simplification is Ax bar into 0 minus dou U by dou Z minus Ay bar into 0 minus dou Ex by dou Z plus Az bar into 0 minus 0 is equal, on RHS side multiplying dou by dou t within the bracket term. We have minus of dou Bx by dou t Ax bar plus dou By by dou t Ay bar plus 0 into Az bar. So that is equal minus dou Ey by dou Z Ax bar plus dou Ex by dou Z Ay bar is equal minus dou Bx by dou t Ax bar minus dou by by dou t ay bar. So comparing on both sides ax bar component and ay bar component, ax bar components are dou e by dou z is equal dou bx by dou t. And comparing on both sides ay bar component, we have dou ex by dou z is equal minus dou by by dou t. But b is equal to mu into h bar. Magnetic flux density B bar is equal to mu into H bar. In the above equation, substitute B is equal to mu into H bar. We have dou U by dou Z is equal mu into dou Hx by dou T, and dou Ex by dou Z is equal minus mu into dou Hy by dou T. For free space, the free space Maxwell's equation is given by, and another differential form of the Maxwell equation, del cross H bar is equal to del cross H bar is equal to dou d bar by dou t. So in time varying case, what is the differential form of the Maxwell equation? Del cross H bar is equal to j bar plus dou d bar by dou t. For free space, there is no conduction current density. So what is the remaining expression? Del cross H bar is equal to dou d bar by dou t. But d bar is equal to epsilon into e bar. Because of that, epsilon into dou e bar by dou t. So similarly, reducing this equation, del is the vector differential operator, that is dou by dou x ax bar plus dou by dou y ay bar plus dou by dou z az bar. And the vector form of the magnetic field intensity H bar is hx ax bar plus hy ay bar plus hz az bar. So LHS term of this equation can be represented into vector matrix cross multiplication of two vectors ax bar, ay bar, az bar, and vector differential operator del ax bar, ay bar, and az bar components, and magnetic field intensity h bar, ax bar, ay bar, and az bar components can be represented into vector matrix form is equal to RHS epsilon into dou by dou t, and vector form of the electric field intensity is Ex Ax bar plus Ey Ay bar plus Ez Az bar. So apply the uniform plane wave condition. What is the condition of the uniform plane wave? For the uniform plane wave propagating in the z direction, it has no x component and no y component. That is, dou by dou x is equal to 0 and dou by dou y is equal to 0. It has no Hz and no Ez components. Along the direction of the propagation, there is no electric field intensity and there is no magnetic field intensity along z direction. That is, Hz is equal to 0 and Ez is equal to 0. Applying uniform plane wave condition into above equation, we have Ax bar, Ay bar, Az bar 0, 0. Dou by dou x, dou by dou y is 0. Dou by dou z, hx, hy, hz is 0. Is equal epsilon into dou by dou t, ex, ax bar plus ey, ay bar plus ez component is 0. Simplifying the above equation, ax bar into simplifying the above equation, we have ax bar into 0 minus dou hy by dou z minus ay bar into 0 minus dou hx by dou z plus az bar into 0 minus 0 is equal epsilon into dou ex by dou t ax bar plus dou e by dou t ay bar plus 0 into az bar. So that is equal minus dou hy by dou z ax bar plus dou hx by dou z ay bar is equal epsilon into dou ex by dou t ax bar plus dou e by dou t ay bar. So comparing on both sides ax bar components and ay bar component, we have ax bar components are dou hy by dou z is equal minus epsilon dou ex by dou t. And ay bar components are dou hx by dou z is equal epsilon dou u by dou t. So now from equation 1, what is equation 1? Dou u by dou z is equal mu into dou xx by dou t. So this is the equation. The general solution of this equation, that is plane wave, will be Ey is equal f1 of z minus c. The equation of the plane wave of equation 1 is Ey is equal f1 of z minus ct. So that is considered as capital F. So differentiating this equation with respect to t, differentiating Ey with respect to t, we have dou u by dou t is equal f1 dash, first derivative, differentiating with respect to time, f1 dash of z minus ct into differentiating with respect to time minus c is constant is equal minus c f1 dash of z minus ct. But f1 of z minus ct is f. f1 dash of z minus ct is f dash, capital F dash. That is the first derivative. That is first derivative. So dou u by dou t is equal minus c f dash, where f dash is the capital F dash is the first derivative. So from equation 4, from equation number 4, dou hx by dou z is equal epsilon into dou u by dou t. Dou u by dou t. But dou u by dou t is equal to minus c into f dash. Minus c into f dash. Substitute dou u by dou t value into equation number 4. We'll have dou hx by dou z is equal epsilon into minus c f dash. That is equal minus c epsilon f dash. Integrating the above equation with respect to z. Integrating above equation with respect to z. So that is equal, hx is equal minus integral c epsilon f dash dz minus c epsilon is constant, that is written before integration. Integral of f dash. F dash is the first derivative of f. Integral f dash dz is f. That is equal minus c epsilon f plus k, where k is the integration constant that can be neglected. Integration constant neglected. So therefore hx is equal minus c epsilon f. But f is equal wave equation, plane wave equation. What is the plane wave equation? Ey is equal to f1 z minus c. That is considered as capital F. Capital F is Ey. Capital F is Ey. And c is equal to velocity of the wave. Wave velocity c is equal 1 by square root of mu epsilon. So therefore hx is equal epsilon into c value is 1 by square root of mu epsilon. Capital F is plane wave, that is Ey. So that is equal Ey by hx is equal take a from this hx is going to RHS side and this mu epsilon is coming to the LHS side and epsilon is also coming to LHS side. We have Ey by hx is equal minus square root of mu epsilon, and epsilon is written as square root of epsilon into square root of epsilon, and numerator and denominator 1 square root of epsilon is cancelled, and remaining expression is Ey by hx is equal minus square root of mu by epsilon. Minus square root of mu by epsilon. Similarly, so from equation 1, the plane wave will be Ey is equal to f1 of z minus ct, that is considered as capital F. Similarly, from equation 2, what is equation 2? and this is equation 2. So similarly, this is the equation. The plane wave is Ex is equal to F1 of Z minus C. Similarly, the plane wave is Ex is equal to F1 of Z minus C. That is considered as capital F. Similarly, Ex is equal to F1 of Z minus At, that is considered as capital F, where C is the wave velocity. So C or V is the wave velocity, that is square root of mu epsilon. So similarly, differentiating Ex with respect to time. Differentiating Ex with respect to time, that is equal dou Ex by dou t is equal F1 dash of Z minus Ct, differentiate with respect to time t, C is constant, that is equal minus C F1 dash of Z minus Ct, that is equal to minus C capital F dash, where capital F dash is the first derivative of F, that is F1 dash of Z minus Ct. So from equation 3, dou hy by dou z is equal to minus epsilon dou ex by dou t. So that is equation number 3. And substitute dou ex by dou t values into equation number 3. We have dou hy by dou z is equal to minus epsilon. What is the value of dou ex by dou t? Minus c f dash. So that is equal to c epsilon f dash. So integrating this equation respect to z, we have hy is equal to integral of c epsilon f dash dz. C epsilon is constant, that is written before integration. C epsilon integral f dash dz. F dash is the first derivative, that is df by dt. First derivative. So integral of f dash dz is f plus k, where k is the integration constant that can be neglected. Therefore, hy is equal C epsilon f. What is capital F? That is plane wave Ex. Plane wave Ex. And what is the C value? 1 by square root of mu epsilon. Substitute C value and F value here, reducing that equation. Ex by hy is equal to square root of mu epsilon by epsilon. In the denominator term, epsilon is written as square root of epsilon into square root of epsilon. Numerator and denominator, 1 square root of epsilon is cancelled. We have Ex by hy is equal square root of mu by epsilon. Ex by hy is equal to square root of mu by epsilon. That is considered as equation 6. But we know that the vector form of the electric field intensity. What is the vector form of the electric field intensity? E bar is equal Ex Ax bar plus Ey Ay bar plus Ez Az bar. Similarly, the vector form of the magnetic field intensity. What is the vector form of the magnetic field intensity? H bar is equal to Hx Ax bar plus Hy Ay bar plus Hz Az bar. So now here for uniform plane wave, propagating in the z direction, along that direction there is no electric field intensity and there is no magnetic field intensity. Along the direction of the propagation, there is no electric field intensity and there is no magnetic field intensity. So there is no electric field intensity and there is no magnetic field intensity. Along z direction components is 0. That is Ez is equal to 0 and Hz is equal to 0. So therefore, E bar is equal to Ex Ax bar plus Ey Ay bar. And magnitude of E bar is equal to square root of Ex square plus Ey square. Magnitude of Ex bar is equal to square root of Ex square plus Ey square. So similarly, magnetic field intensity, vector form of the magnetic field intensity, H bar is equal to Hx Ax bar plus Hy Ay bar plus Hz Az bar. For uniform plane wave, along z direction, there is no magnetic field intensity, that is Hz component is equal to 0. Therefore, H bar is equal to Hx Ax bar plus Hy Ay bar. So calculate the magnitude of H bar. Magnitude of H bar is square root of Hx square plus Hy square. So now consider magnitude of E bar expression. Magnitude of E bar is square root of Ex square plus Ey square. So from this equation, Ex is equal square root of mu by epsilon into H pi. From this equation, Ex component Ex is equal to square root of mu by epsilon into H pi. And from equation number 5, from this equation, the component Ey is equal to minus square root of mu by epsilon into Hx. So magnitude of electric field intensity. What is the magnitude of E bar? Square root of Ex square plus Ey square. In this equation, substitute Ey bar component value, and equation number 6, substitute X bar component value. In this equation, substitute X bar component value. Okay. Therefore, magnitude of E bar is equal square root of Ex. What is Ex component? Square root of mu by epsilon H by whole square. Square root is cancelled. Mu by epsilon into H by square plus Ey component is minus square root of mu by epsilon into Hx. So minus 4 square is plus square root is cancelled plus mu by epsilon Hx square. So on both the terms mu by epsilon is common, that is equal. Capital E is equal square root of mu by epsilon into square root of Hx square plus Hy square. So what is the value of square root of Hx square plus Hy square? That is magnetic field intensity H bar. Magnetic field intensity H bar. E is equal square root of mu by epsilon into H. H is coming to the LHS side. We have E by H is equal square root of mu by epsilon. So E by H, the ratio of magnitude of electric field intensity to the ratio of magnitude of electric field intensity to magnitude of magnetic field intensity is called as intrinsic impedance. The ratio of magnitude of electric field intensity to magnitude of magnetic field intensity is called as intrinsic impedance, and it is denoted by symbolically intrinsic impedance eta. Eta is equal E by H. That is equal square root of mu by epsilon. Square root of mu by epsilon. So for free space, the intrinsic impedance is denoted by eta naught. So electric field intensity is measured in volts per meter, and magnetic field intensity is measured in ampere per meter. What is the intrinsic impedance? E by H. Volt per meter by ampere per meter. So numerator and denominator, meter is cancelled. The intrinsic impedance eta is equals volts per ampere. That is R by I. V by I. So that is impedance. The dimensions of intrinsic impedance is impedance, ohms. The dimensions of intrinsic impedance is ohms. So for free space, the intrinsic impedance is denoted as eta naught. For free space, mu is equal to mu naught and epsilon is equal to epsilon naught. For free space, what is the permeability of the free space? 4.10 to the power of minus 7 Henry per meter. And what is the epsilon naught value? 8.854 into 10 to the power of minus 12 farad per meter. And substitute here mu naught and epsilon naught values, we get 125 ohms or 377 ohms. In free space, the value of intrinsic impedance is 125 ohms or 377 ohms. Now calculate the dot product of E bar and H bar. Now determine dot product of E bar and H bar. So what is the vector form of the electric field intensity? E bar is equal to Ex Ax bar plus Ey Ay bar plus Ez Az bar. And what is the vector form of the magnetic field intensity? H bar is equal to Hx Ax bar plus Hy Ay bar plus Hz Az bar. For a uniform plane wave propagating in the z direction, along the z direction, there is no electric field intensity and there is no magnetic field intensity. Because of that, the vector form of E bar and H bar are Ex Ax bar plus EY bar and magnetic field intensity is Hx Ax bar plus Hy Ay bar. Now take the dot product of E bar and H bar. Dot product of E bar and H bar is equal Ex Ax bar plus Ey Ay bar dot Hx Ax bar plus Hy Ay bar. So, but we know that dot product of same unit vectors is unity and dot product of different unit vectors is 0. So, the RHS term of the above equation is Ex Hx plus Ey Hy. But we know that what is the component of the Ex? The component Ex is equal square root of mu by epsilon Hy and component Ey is equal to already calculated and substitute the component Ex and Ey components here. So that is equal, after substituting Ex component and Ey component, that Ex and Ey components already calculated in this class. In this class already calculated. Okay? 0. E bar dot H bar is equal to 0. So what is the dot product between two vectors? A bar dot B bar is equal to AB cos theta. E bar and H bar are the vector quantities. E bar dot H bar is equal to EH cos theta. EH cos theta is equal to 0. So therefore cos theta is equal to 0. Theta is equal to 90 degrees. So theta is equal to 90 degrees means in uniform plane wave propagating in the z direction, the electric field intensity and magnetic field intensity are perpendicular to each other. Electric field intensity and magnetic field intensity are perpendicular to each other in uniform plane wave. So now calculate cross product of E bar and H bar. So what is E bar? Ex Ax bar plus Ey Ay bar and H bar is Hx Ax bar plus Hy Ay bar. So now take the cross product of E bar and H bar. E bar cross H bar is equal. Ax bar component is in vector form the electric field intensity. Ax bar component is Ex, Ay bar component is Ey, Az bar component is Ez. So for uniform plane wave, there is no Ez component. Ez is equal to 0. And H bar vector, Hx, Ax bar component is Hx, Ay bar component is Hy, Az bar component is Hz. Along the direction of the propagation, there is no Hz component. Hz is 0. So simplifying this equation, E bar cross H bar is equal, E bar cross H bar is equal, Az bar into Ex Hy minus Hx Ay. And substitute in this equation Ex components and Ey components. Ex and Ey components already calculated in the same class. Substitute that Ex and Ey components. After substituting, we have Az bar into Ex component is square root of mu by epsilon Hy into Hy minus Hx into Ey component is minus square root of mu by epsilon Hx. So that is equal Az bar into square root of mu by epsilon Hx square plus Hy square. Hx square plus Hy square is H square. So what is square root of mu by epsilon? That is intrinsic impedance eta. So therefore, E bar cross H bar is equal eta H square Az bar. Eta H square Az bar. So that is the cross product of E bar and H bar. So this is the concept of mutually perpendicular relations between E bar and H bar in uniform plane wave concept.